Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P2123 indicates a specific issue with the Accelerator Pedal Position, APP Sensor A, which is analyzing the throttle position, TP Sensor D circuit. This error signifies that there is an abnormally high voltage detected within the circuit. The role of the APP sensor is crucial in regulating engine power delivery by monitoring the accelerator's position, which sends signals to the engine control module, ECM, to adjust throttle response. The APP sensor is typically located near the accelerator pedal assembly, making it easily accessible for inspection and troubleshooting. The circuit high voltage issue can lead to performance setbacks, including poor throttle response or engine stalling. Proper verification of the error is essential to determine the appropriate steps to take and repair the condition effectively. DTC P2123 specifically points to a malfunction within the accelerator pedal position sensor A, commonly referred to as the APP sensor. The symptoms are identified through high voltage readings within the circuit. This APP sensor plays a critical role by ensuring the engine receives the correct throttle position information for smooth acceleration and optimal performance. Typically situated close to the accelerator pedal assembly, this sensor's position allows it to efficiently gauge how much the accelerator is pressed. When high voltage is detected, it can disrupt the communication between the APP sensor and the engine control module, ECM, leading to potential throttle issues. Thus, understanding the exact role and location of the APP sensor is essential for effective diagnostic and repair processes. Several potential causes can lead to the occurrence of DTC P2123. The first and foremost possibility is a faulty APP sensor, which may not accurately communicate the throttle's position due to internal malfunctions or wear and tear. Next, poor connections can arise from corrosion or improper fit, affecting the electrical signals transmitted between the APP sensor and the engine control module, ECM. Loose terminals are another critical factor that can disrupt the electrical circuit, leading to voltage readings that are inconsistent and unreliable. If the connections are not secure, the vehicle may experience intermittent failures along with other performance-related issues. Each of these causes highlights the importance of ensuring proper electrical integrity throughout the APP sensor circuit. The symptoms associated with DTC P2123 can significantly affect the driving experience. Drivers may notice poor throttle response when attempting to accelerate, as the engine may not receive accurate readings regarding the position of the accelerator pedal. This miscommunication can lead to hesitations, where the engine does not deliver power as expected. Additionally, engine stalling may occur due to the disruption in throttle control. The engine may struggle to maintain idling speed. In some cases, the accelerator pedal may become unresponsive, leaving drivers unable to accelerate the vehicle even when the pedal is fully depressed. Recognizing these symptoms early can help avoid potentially dangerous situations on the road, making it crucial for vehicle owners to address any DTCs promptly. The first step in troubleshooting DTC P2123 involves verifying the presence of the issue. To do this, turn the ignition switch to the on-to position without starting the engine. With the Honda Diagnostic System HDS in use, check the voltage reading on the APP sensor A located within the data list. The expected reading is around 4.9 volts or higher. If the reading confirms this voltage, it indicates that the failure can be duplicated, and you should proceed to step 2. However, if the reading does not meet this threshold, it suggests that the system is working intermittently or correctly at this moment. Therefore, you should check for poor connections or loose terminals at both the APP sensor and the ECM to ensure reliable operation. In the second troubleshooting step for DTC P2123, ensure the ignition switch is turned to the lock 0 position for safety. Disconnect the 6P connector from the APP sensor to proceed with the voltage measurement. Then, turn the ignition switch back to the on 2 position again. With the connector disconnected, you will measure the voltage between 2 designated test points. These test points are located on the APP sensor 6P connector. Specifically, test point 1 is number 5, colored blue, and test point 2 is number 6, colored brown. You should expect to find a voltage reading close to 5.0 volts. If this voltage is present, replace the APP sensor and proceed to repair verification. However, if the voltage is not reading as expected, continue on to the next step to investigate further. The third troubleshooting step focuses on testing the SG4 wire line for continuity, which could contribute to the P2123 issue. Start by turning the ignition switch to the lock 0 position. This prepares you safely to jump the SCS, service check signal line, using the HDS. After that, disconnect the ECM connector A49P to isolate the circuit appropriately. It is crucial to use a jumper wire to connect terminal A from the APP sensor 6P connector number 5, which is blue, to body ground. With this jumper wire setup, check for continuity between the specified test points. You will be assessing the connection from the ECM connector A49P, number 46, colored blue, which corresponds to the SG4 wire. If continuity is present, the SG4 wire is functioning correctly, and you should consider updating the ECM software or substituting the ECM. However, if continuity fails, this indicates a potential break in the SG4 line, necessitating repairs before continuing the troubleshooting process. After the necessary repairs have been executed, it is essential to perform a final verification to ensure the repairs were successful. To do this, start by turning the ignition switch to the lock 0 position for safety. Then, reconnect all connectors that were previously disconnected during the troubleshooting and repair process. Once everything is securely connected, turn the ignition switch to the on 2 position. It is critical to reset the ECM, or engine control module, using the Honda Diagnostic System, HDS. Following this, perform an idle learn procedure to recalibrate the system to new operational standards. Once these tasks are completed, check for any pending or confirmed DTCs to see if DTC P2123 has been resolved. If DTC P2123 is still indicated, further investigation into connections may be required. However, if everything checks out, this means the repair process has been completed successfully. In conclusion, managing DTC P2123 in a Honda Civic from 2011 to 2015 involves a systematic approach to troubleshooting the APP sensor circuit. Start by verifying error symptoms, including poor throttle response and engine stalling, which signal issues related to improper APP sensor function. The first troubleshooting step focuses on checking voltage readings and connections. If necessary, replace faulty components and verify proper wiring to ensure accurate signals to the ECM. Lastly, follow the final repair verification steps to confirm the successful resolution of the DTC. By understanding the components involved and the diagnostic process, vehicle owners can effectively address potential issues, ensuring their Honda Civic operates smoothly and reliably. Please like and subscribe to the channel. See you next time.